Hey guys, I'm Maddie, and in this tutorial, I'll be covering Module 12, Electrochemistry, with emphasis on corrosion. To take us back through a little bit, here we see a list of things we had covered in Unit 12, along with it being electrolysis, cell potential, and more. But first, we will begin with a brief review of redox reactions. So by now, we all should know that a redox reaction is a reaction involving the transfer of electrons from one species to another. And I'm showing you this because redox reactions are at the center of the reason behind corrosion and many other things that we see in our daily life. During corrosion and these other electrochemical events, the redox reactions that occur must be split into their half reactions and balanced to determine which metal is reduced and which is oxidized. As you will see, this will be very impactful on rust prevention covered later in the tutorial. But right now, I'll take you through a very fast example of a reaction between copper and zinc. In this scenario, we see solid copper react with copper sulfate to form a copper solid and a zinc sulfate. First, from the periodic table, we find zinc to have an oxidation state of 0, and copper sulfate must be neutral, which means to balance the -2 of the sulfate ion, copper must be copper 2+. On the right, we see the reverse. With copper now being a free element, it will have an oxidation state of 0, and zinc now must be 2+ to neutralize the sulfate ion in the compound. As you can see in our overall reaction, zinc went from an oxidation state of 0 to 2+, and it has been oxidized, and copper, being the reverse scenario, has been reduced, as it has gone from a state of 2+ to 0. Branching from our review of redox reactions, I'm going to take you through another brief review, this time on galvanic cells, which use the properties like the spontaneity of redox reactions to generate usable electricity. To begin, we see the electrodes submerged in their corresponding solutions and cells, which you have determined using the half reactions below and the memory mnemonic which you have determined using the half reactions below and the memory mnemonic Leo enjoys Ricard, which means left anode oxidized and right cathode reduced. To give you a rundown on how the system works, we start by seeing that the copper solution has dissociated to create a source of electrons and free copper, making this cell a negative anode. We also see that the silver solution has dissociated as well, but instead, the free silver ions begin to build on the silver electrode, increasing the mass, leaving a surplus of nitrate, which makes this our positive cathode. We see movement of electrons from our negative anode to our positive cathode, but because of this, we also see a buildup of copper 2+ in solution, making our copper solution more positive. To balance this increase, we introduce a salt bridge to allow ion flow and neutralization by pulling nitrate into our copper beaker. In the end, we see a value on the voltmeter from this movement, which is also known as the cell potential, given by the following equation. Now to take you into the main topic of corrosion, which is simply an unwanted galvanic cell that uses undesirable redox reactions. Corrosion, like a galvanic cell, uses the spontaneity of a redox reaction to break down metals. By spontaneous, I mean that the reaction occurs with no external stimulus, only requiring exposure to some source of oxygen, which is in fact found everywhere, like air, water, and soil. We see many different kinds of corrosion, such as galvanic corrosion, corrosion between two metals, electrolytic corrosion, corrosion between a metal and electrical equipment, or even rust, which is a subcategory of corrosion, which requires both exposure to water and air, which often corrodes iron. We see corrosion occur in most metals that have high reactivities as they are more likely to participate in a redox reaction. These being metals like iron, magnesium, and aluminum. Corrosion is also more likely to occur when the environment is hot and humid, while pollution can also play a role through the process of acid rain, because acidity also promotes corrosion. We see corrosion be so impactful to society because we use metal everywhere. It can cause the collapse of infrastructure, bursting of pipes, floods, and can also cause electrical issues. All of these, which are extremely costly and unsafe to us. An example close to home is our very own Parliament buildings and their green roofs. Now, originally, the roof was copper with a bronze color, but over the years it has been oxidized by the air into a more stable form. Where corrosion can be very bad usually, here it has formed a protective layer over the metal which protects the roof from further degradation. Unfortunately, the same cannot necessarily be said about the Statue of Liberty. The same process has occurred on the outside, but due to the monument's iron structure, the whole statue is like one big cell, and it has caused the inside to crumble, costing nearly half of the frame in only 100 years after being built. There are a magnitude of ways to protect against corrosion. The first we are going to cover being cathodic protection. Cathodic protection involves creating a cathode out of a metal at risk by putting an anode device on the surface to provide free electrons. For this to work, the anode must be a metal that is more reactive than the one at risk, which often turns out to be zinc, magnesium, or aluminum. We can see this device commonly used in boats to protect against seawater, as the salt makes the water an electrolyte, providing optimal grounds for corrosion. The downfall to this is that the device can be costly and requires routine maintenance and often needs other methods like galvanization when applied to larger surfaces. The next method we will discuss are alloys. Alloys are another method of protection for corrosion, which involve mixing multiple metals together. In doing so, the metals react with each other rather than oxygen to produce protective layers that prevent any further reactions occurring. It is one of the best It is one of the best preventative measures as it does not require maintenance, and different alloys provide different benefits to the users. We see a downfall, though, in this method through cost, as it can be quite expensive depending on the alloys created. The last method we will review is galvanization. This process involves dunking a metal, often steel, into molten zinc. This is effective because metals like iron present in steel will react with zinc to create a tight barrier against external oxygen. It is known to be a relatively sustainable and low-cost method, but it is required to be done in the right setting. By this, I mean companies must bring the metal they wish to protect to a factory, and it cannot be done on the spot. It has also been proven to be toxic due to the fumes produced from the molten zinc. So this is the end of my tutorial. I congratulate you guys, and you have now learned and reviewed redox reactions, galvanic cells, corrosion, corrosion prevention, and much more, and I hope you enjoyed. Thank you.